Welcome to a Build Up webinar. These are webinars that we hold periodically, sometimes more often, sometimes less often. Essentially, when we have cool things to share, cool things to talk about, topics that we want to cover. And this topic is something that we get a lot of questions about, which is about Phoenix generally, which is the open source social media listening tool that we provide along with Data Value People. But really specifically, like what are tax classifiers and how are Peacebuilders actually using them? Like how is a sausage made? When we're talking about Peacebuilders using AI, what exactly does that mean? And so that is what we're covering today. We have Benjamin. Hi, Benjamin. I'll let everyone introduce themselves, but Benjamin from Data Value People, Alan and Elena from Build Up, and I am Julie also from Build Up. The way that this works is that these three will present and then we'll have time for questions. There is a Q&A feature on the webinar at the bottom of your screen called Q&A. You can put it there, and I'll also try to monitor the chat for questions that come up there. But if you definitely want your question answered, put it there in the Q&A. And you can input it at any time throughout the session. So whenever you're feeling inspired. All right, with that, I will pass it over to these three. Thank you and enjoy.
Shall we do quick intros first before we get started? So my name is Elena. I'm one of the co-founders of Build Up and the strategy lead. And I actually wasn't supposed to be speaking at this webinar. I'm covering for Rita, who couldn't make it in the end. So I'll do my best to fill her shoes. Alan, do you want to go next?
Yeah, sure. Thank you. Hi, everyone. My name is Alan Cheboy. I'm the data and digital technology lead at BuildUp, and I'm looking forward to this. I'm based in Kenya, in Nairobi. We have quite a lot going on after the death of our former prime minister earlier today. So in case of anything, or in case my network isn't as stable, it's because of things that are happening in the country. But welcome all, and looking forward to this discussion. Yeah.
The last person is I'm Benjamin Svigo. I'm the founder of Data Value People. I'm one of the lead engineers on Phoenix. I'm based in Amsterdam, and I'm looking forward to trying to communicate some information and hopefully get inside the black box of all this classifier stuff. Let's have a look at the sausage. I think I have to share my screen to get started.
Yeah, you're the first one to look at the sausage, Benjamin.
Yeah, let's start with the sausage then. Okay, so here we go. Can everybody see my screen? Yeah, good. Okay, so let's start with like why are Peacebuilders building classifiers? So in Build Up, the work we do, we mainly start with social media. So to answer this question, we need to answer like why are we doing social media analysis for Peacebuilders? And in general, I think that Peacebuilders are trying to look how they can affect a conflict for the better with some initiative. And to do this, social media analysis can help us because it can help build a representation of the dynamics and drivers within a conflict. And they can look at how it's played out on social media or in a digital public space. Here's an example of that. So an example of analysis we could do is we could use hate speech as a measure of the level of conflict on social media in Kenya. Something we've been looking at, something similar than we'll be looking at. And how could we use classifiers to do this? Classification could help. Could summarize all of the social media data in a single number. So, what's the percentage of hate speech across all this huge amount of data into a single number that can give us some insight and creates a representation of the drivers, maybe. We can also use it to filter relevant data that we're looking for. And then maybe we could do a qualitative analysis based on what we filtered and what we found. And these are some concrete examples of what we could do. And then how do we do that? So when I first joined Build Up, there was somebody called Christelle, I think other people in Build Up probably did it, but they put all of the messages into a spreadsheet and they went through and they started like labeling them. I'm sure that people who are interested in classification have also done this. I've done this. And it's a great way of like classifying stuff, right? You just have a human and they just use their human, whatever knowledge and abilities to be able to classify things. And that would give us might be able to give us a percentage of the hate speech. There's no fine-tuned model needed here. There's no like clever machinery. There's no cool stuff. It's just a human like looking at how we can classify something, and we can get the percentages of the hate speech in this example from this. And actually, we can also do this for larger data sets using statistics and like taking a random sample and looking at confidence intervals. We can find out information about the percentage of the hate speech or the prevalence to do this. So we don't need machinery, but there's some cases where we do need machinery or fine-tuned classifier. And in those cases, it's when we get a new example. What are we going to do with the new example, right? For instance, maybe Christelle is not working anymore. Like she's not going to do any annotation. She's not going to label this example. What are we going to do? Yeah, and we could use a fine-tuned classifier for that. And also, if we want to find like a bunch of relevant data, say if we've got a huge amount of data set and we want to find a relevant data points within there, then using classifiers can help us do that. Whereas like in contrast to the prevalence or the percentage, finding actual data points that are specific, they're interesting to us, is good with automation. And in the end, you know, we're kind of thinking about how we could use classifiers as a measuring tool, although this is very difficult and resource heavy. It's kind of maybe an end goal. So yeah, let's build a fine-tuned classifier. Here we go, deep into the sausage. So first thing, classifier, the word classifier is the same as model. It's the same as recipe. Hopefully we can always all of us understand what a recipe is. It's it's something that we get a bunch of information. We have a recipe and then we produce an answer. We make some decisions about it and we produce this recipe for how we get from the information to the answer. In like technical terminology, we use examples, model, predictions. So the predictions are the answer, the examples of the information, and the model is the recipe. And yeah, how do we get the answer for this new example? So here's one very simple classifier. It's a keyword classifier. Maybe you guys have all done this. You say, if the text contains a word, then we classify it for positive. For instance, if it contains some swear word, then it's classified for hate speech. So a human thinks about the patterns of hate speech and creates a program, a recipe for doing this. So the human uses their abilities and they come up with a recipe and a pattern that takes the information and produces the answer. This is one way of doing it. I'm sure if people have tried it, it's all right. Does some good things well, but it does some things not so good. So we can start to look at complex classifiers like fine-tuned classifiers or machine learning classifiers. And in this point, the machine is going to work out the patterns for the hate speech from the examples. And also the idea of fine-tuned comes from, we have a model that already has like all the patterns, lots of the patterns of language in it, and then we fine-tune it. We'll get into this further, but you can understand it as the information. We have the recipe is produced by the machine learning, and then we get the answer. And the machine learning is actually just maths. It's mathematics. But we have a problem here, right? The information is text and the machine learning is maths. So how is the machine learning going to understand the text? And then we get to this a bit interesting part, which is how can we do maths on text? And we get to something called embeddings. The embeddings take a word and its meaning and turn it into a number. And so you can think of it as a sort of numerical compressed representation of how we think about words and how the relationships of words emerge. And it's kind of these embedding machinery has come from like having machines process huge amounts of data, like all the data on the internet or all the data on Wikipedia and that kind of stuff. So let's have a look at one. Here's a word to vec. Hopefully this will help us. This is called word to vec 10K. Ooh. So let's have a little look at the word king. How's it going? Yeah, so here we see the whole space of vectors, numerical space of all the words. And there you can see here down here, can you all see this or is it too small? Yeah, there's the king. And we can see some things that are close by. So you can see queen is close by to king, throne is close by to king. So you can see this in this space, the numbers and their distances are representing how close concepts are. Let's have a look at another one. Queen. So interestingly here, the closest match to Queen is Elizabeth. So we all, well, in Britain, Queen Elizabeth is well known. So interestingly, this is probably showing some bias within the data set about what's going on. So yeah, hopefully that gives you a sense of what it means to take a word and put it into a number. And there's other machinery that does that, not just the words effect we looked at. There's BERT, which we've used as base models before, and there's GPT. ChatGPT is based on that, so gives you a sense of what's going on there. And so once we've got the vectors, the numbers, we can do maths on them. So this is a classic example. We get the vector of king, we minus the vector of man, and we add the vector of woman, and then we get the vector of queen. Yeah, the closest by vector is queen. There is a bit of a point there, which I'll point out, but it allows us to see that with these numbers, we can do maths on the meanings. Okay, so now we've got numbers, we've got text to numbers. Now, how are we going to find a pattern? So what is fine tuning? So imagine that space we just saw with vectors. Now we're going to show it in 2D. So imagine that Christelle or somebody from BuildUp, they've labeled a whole bunch of examples. In this case, I think it's like 10 or 12. And then some of them are hate speech and some of them are normal messages. But this is our graph of our examples. And now we want to find a pattern of this. Like a human could probably draw like where the regions are in the graph that are normal and where the regions are hate speech. So let's have the machine do it. So we can do it with a straight line. It's called linear regression. And you can see it's okay, but we're missing some stuff here. It's not quite hit correctly here. And then we can do it with a curvy line. Neural networks produce a more curvy line through the space. And that works better. So yeah, if we've got these two regions in this decision boundary, we can say, okay, there's a new example. What's the answer? Yeah, it's hate speech. So from there, we have the information. The machine takes the text as numbers. It works out the pattern and it produces a mapping from the numbers to the classes, the vectors to the classes, and it gives us an answer. Yeah, and this is kind of how machine learning works. So in conclusion for this section, we'll get into more depth later. Classification is used for social media analysis. Classifier model recipe. We have text, words, the vectors, and we use ML, mathematical patterns, to work out mathematics to work out the patterns within these vectors. And if you're like interested in getting really deep into ML and machine learning, there's a great full course from Google about machine learning, which kind of I've taken bits and bats from them, but they go much more in depth, so I recommend it. I'll give you the link as well at the end. I'll hand it over to Alan.
All right. Thank you, Benjamin. So I'll just maybe take over the screen sharing for a quick one. Yeah, so just to expound a little bit more on specifically why we are even building these classifications. And like, there are so many reasons why Peacebuilders would actually build these classifications. I just kind of tried to identify a few that as BuildUp we've focused on before and where we see a lot of our partners kind of using or building machine learning models to kind of address different issues. So this could range from issues around online bullying and harassment. So trying to build models that will be able to identify cases of harassment and how that looks like. The example that Benjamin just mentioned on online hate speech is something that a lot of Peacebuilders focus on. Some people just want to map levels of incitement to violence in a particular setting or in a particular context. So in those cases, they will build a machine learning model that kind of identifies, how statements related to violence and insightful language are being discussed on different digital platforms. In the past, as BuildUp, we've also tried to kind of build an intimidation identification model in the Sahel region of Africa. And it's kind of, something that will be interesting because sometimes you want to figure out, okay, if I have an account on Facebook or if I have an account on X and people come and comment on my posts, or basically, retweet my posts with some content, are they intimidating? Are they, what is the level of intimidation in those responses, especially on comment section? We've seen attempts of people trying to figure out ways of kind of using machine learning models to identify disinformation and misinformation. Gender-based attacks is something that many organizations are currently focusing on. Sometimes it's just to identify popular narratives and attitudes and sentiments and just behavioral assessment across different online spaces. So there could be a lot more that you can focus on when it comes to peace building. So I'll just give a few examples of where we've applied this and the new feature, especially that we've added to Phoenix. So we had a project in Somaliland, and this project was focusing more on identifying narratives that are related to the electoral process in Somaliland. And this then, one of the things within that particular research was to try and identify toxic content that kind of were being seeded into the conversation within about elections in Somaliland. So this is something that we were working together with local peace builders to implement. And the exciting thing about this is that we went through this particular process of, okay, we have a bunch of keywords that we consider to be related to elections. So we used those keywords to create keyword classifications just to enable us to see what are the popular topics, which are the popular entities that are being discussed on social media in relation to elections. And then now we combine that with an application of a model that is called an open source model called Perspective API, which is built by Jigsaw at Google. And it's an open source model, so it's already linked onto Phoenix. And when you apply that model, you're able to try and figure out, okay, are there any toxic posts that kind of are seeded into conversations about elections in the country? And that was a powerful representation because it enabled us to kind of have visibility of which entities, when they are mentioned. For example, is it the National Electoral Commission of Somaliland? Is it political parties? Is it one political party over the other political party that we see a lot of toxicity being mentioned in relation to those particular entities? So it's a really powerful way of peace builders try to make sense of where we see a lot of polarizing content or toxic content being seeded, especially targeted at different actors in a setting that you're looking at. And the other thing that we also did is because within Phoenix, we've now introduced a process where you can actually upload or use an existing open source classification model from Hugging Face. So we also applied one that we trained by ourselves. So because Perspective API is only trained in English and a few other languages, so we identified that there was a lot of limitation because a lot of the content in Somaliland were actually in the Somali language. So we actually built and trained and fine-tuned a classification model that could then be able to try and understand the Somali language and especially toxicity in the Somali language. And this combination of classifications from like a keyword classifier to identify popular narratives and actors to Perspective API that then identifies the toxicity in English and more popular languages to now a more custom classification model that identifies content that is in local language and in local context. That became a powerful way of now visualizing that data. So this is the dashboard that we built for this, and this is basically now Perspective API telling us that, oh, I know in your data, and this was about 1.2 million pieces of content that we collected that were talking about elections, about 832 pieces of content have a very high probability of toxicity or insult or identity attack or threat. So this was a really, really powerful way of now trying to identify areas of toxicity and which groups or actors are actually being targeted when it comes to the level of toxicity that we see on social media in these cases. So that is one of the case studies that I wanted to mention. And then the other thing that maybe would be an interesting one is, because I mentioned this can be applied to any topic. So in Nigeria, we actually applied the same process, but there was a slight difference in the Hugging Face classifier that we applied. And the reason is that in Nigeria, we're looking more on like, narratives around religious intolerance, and this will then enable us to kind of create initiatives around, and dialogues around, the denominations that are kind of, involved in this in these interreligious, issues within the context. And one of the things that we did in this is we had the keyword classifications similar to what we did in Somaliland, but these were more relevant to religious intolerance as a topic. We also applied Perspective API. So the beauty of this particular project was that a lot of the content was in English, because a lot of people also speak English in Nigeria. But then we identified that there was a person, a developer somewhere, who had created a model and uploaded it on Hugging Face. And this model was able to identify, toxic content, but in local language in Nigeria. So this is not something that we trained ourselves. It's something that we actually found on Hugging Face, because it's something that worked, and it worked for us, and it was interesting. We were then able to apply this to the data directly. And this then, was looking at specifically abusive language in these conversations in relation to intolerance. And we were able now to figure out, are there content on different platforms that the model that we've actually just found open source in the on Hugging Face, and it is trained by someone who's based in Nigeria. It was able to identify almost 100,000 posts that it considered to be abusive. So that was a really powerful way of combining a machine learning indicator to actually the data and the normal keyword classifications that that you're supposed to be looking at. Yeah, so that is one of the ways that I feel will be really, really powerful when applying these particular machine learning models on the data that you're collecting, either on social media or any other digital platform. And it's a powerful way for peace builders to actually tell stories that are more relevant and targeted in different contexts. So I'll hand over to Helena to just
Can you actually
walk us.
do you mind keeping the slide share, Alan?
Yeah.
Just to make it
All right.
quicker.
That's fine. Just there you go.
Okay, brilliant. So we've just seen what it takes to sort of build a classifier in the way Alan was describing it, and the reasons why, the way that Benjamin was describing it, and the reasons why peace builders may want to use them or to build them themselves, which is what Alan was getting into. Can I have the next slide? So what Alan was showing is that there has been a lot of work to build complex classifications, and that, for example, you can find some on Hugging Face, but there are instances where we've seen that existing classifiers don't really work. And there are multiple reasons for that. It can be that they can only read a language, so it could be French, for example, and we want to use them in countries where multiple languages are used on social media. So, for example, in Mali with Hausa, and so we wouldn't be able to get the full picture, or because simply they just don't work in certain languages. So, for example, Perspective API, which we were just talking about, only works in a number of languages. So if we go briefly back to the example that Alan discussed on Somaliland, Perspective API works in English and in Arabic, both languages that are spoken in the region, but it doesn't work in Somali. So because we were interested in the level of toxicity on a specific conflict in Somaliland, not classifying and therefore not understanding Somali language meant that we would be missing a very big part of the narrative. Can I have the next slide? So this is what it does classify, what Perspective API does classify in English. It's got quite, it's quite a useful kind of set of classifications that you can look at. But what we decided we needed to do was essentially use Perspective API and build it in Somali. And to do that, the first thing that we had to do was set up a process of annotation with 6 different annotators, which the annotation process itself, Alan will talk about it briefly right after I speak, but then also we're going to have a whole webinar just about the experience of annotation, where you'll be able to hear directly with some of the annotators we've worked with in Kenya and in Sudan. We'll tell you the date and the time of that next webinar towards the end of this one. But what we had to do was work with annotators and critically agree on the definitions. So we thought to ourselves, what would the Perspective API attributes look like in Somali? So not expecting anyone necessarily on this call, maybe we have some Somalis, but to necessarily understand this, but this is kind of where we where we went to first. And so we had to sort of agree and contextualize the what that we are classifying. That was the key to the beginning of this training, the classifier. So can I have the next slide? So the main thing that we did was that in a workshop with different Somaliland civil society organizations and the annotators, we brought the definition of Perspective API in English, translated it into the Somali version. And then at that workshop, what we did was further contextualize it. So we guided by the participants, we changed some of the terms, but also some of the definitions of what was and wasn't included under being toxic. And that's quite a granular discussion. So, you know, I'm saying it like that as if it's a simple thing, but it's not a simple thing. And I wasn't actually a part of the Somaliland work, which is why Rita was supposed to do this, but I was part of a very similar piece of work that we did in Kenya. And I remember a very long discussion with Alan and Caleb and myself about whether a post that is rude is polarizing or not. And the answer in a nutshell that we came to was it depends who it's being rude about and in what way. Not all rude posts are also polarizing. So it's these kinds of definitions that are really important to the classification process, kind of from the peace building perspective. Just one more example before I hand back to Alan is that we built a classifier to look at intimidation in Mali, Burkina Faso, and Niger. And while there were some classifiers that looked at hate speech in French, most of them had been trained with French annotators and looked at sort of a broader spectrum of hate speech. So they were neither contextual nor actually entirely relevant to the specificity of intimidation. And in that piece of work, we wanted to identify the different levels of intimidation people got when responding online. And so we fine-tuned the model in that direction, in the direction of that specific definition, and with with annotators that were context experts and not just language experts. So that's just a little bit on the how. And Alan is now going to talk a little bit in more detail about the basics of the annotation process and the building of the classifier.
Yeah, thank you. Thank you so much, Helena. So I think one of the things that we kind of learned earlier on was the annotation process needs to be meaningful, meaningful at the end of the day. And the selection of the people that are going to develop the classification, if you're doing a custom classification, was a very important part of this. And this basically means that, you know, in the context of building a classification model, one thing that we strategically did as build-up is we engaged people who care about that particular topic. So this is an example for Kenya where we were looking at, you know, how do we define polarization or polarizing content and build a model that tries to understand polarization in the local language. And as you can see, this is in Swahili, and it tries to like look at, oh, this group of people are foolish people. So is that like not polarizing? Is that maybe? Is that probably? So kind of trying to figure out like, you know, how do you build this? But the main idea here was to bring in people that care about that particular topic. So when we started working with the annotators, one thing we did is we actually went to a group called FECOMO in Kenya. So it's like people who are experts in freedom of expression issues, people who are experts in toxicity and polarization, and have worked in these spaces from a government, from civil society, from media. So we kind of came up with people who are in diverse sectors that are working and care about the work. And when we brought them in, the annotation process became quite interesting because for them, they were like, all right, once we finish this, I'm going to try and apply it, you know, based on the context on the work that I do. And that became a very interesting thing for them to do because the annotation process also is something that was really resonating with them, just seeing those posts and labeling them and figuring out what next. But essentially how the process looks like is that, you know, you have this bunch of data that you've collected and you're able to split it into chunks. And this primarily you also have a training set of data and then a data that you'll be able now to test the model with. But this set of chunks that you've created are really important, and you'll see it because at the end of the day, this process becomes very iterative because it has to be like a process that you try and then, you know, you label a little bit more of data, you label a little bit more of data, and that becomes a model that is a little bit, you know, more refined or fine-tuned in a sense. So in the Kenya in the Kenya context, what we did also is before we went and did a training for the annotators, because as Elena mentioned, you have to come up with the definitions, and the annotators or the people you're working with need to understand the definitions so that when they meet the piece of content as they are doing the annotation, it's easier for them to identify based on the definitions that you've kind of developed in that process. We created this data set with examples of really, really polarizing content in the context of Kenya. And this content is something that, we basically went and found online, and you are able to use those as examples in the training, so that we're able to say, when you see this type of content, this is actually just something that is rude. When you see this type of content, it's actually content that is polarizing, and we are able to use that in a way that is a little bit more meaningful to do the training on. And then now we went into the cycle of annotation, and the annotation, in this case, we had like round 1 to 10. And what that means is that for these chunks of data that were split initially, so we give like 1,000 posts to the first round, or 500 posts, or 200 posts, depending on like how you want to split that up. And you show it to the annotation team, and they're able to label it using this particular process where they can say, oh, I've read that. Is it polarizing? No. Is it this? Yeah. And they can be able to say, this and this and this. And then once you finish that first round, you actually have a meeting to discuss disagreement. And that was a very, very important part for us, because what we realized is that something that I consider to be toxic or polarizing or intimidating, depending on what you're building, the other person might not actually consider to be the same. So you have to kind of have this cycle of what was the reason why you decided to say that this is polarizing, and I didn't find it as polarizing, and then you come to an agreement, and then now you kind of redo this in the next round, and then you have a new set of data, you kind of annotate it again, have a disagreement analysis meeting or like a session, and then that cycle continues until now you're able to make sure that everyone is on the same page in terms of like the data set that has been finally annotated. And then now this moves now to the dev team, who then are able to do the modeling behind the scenes in order to make it something that becomes efficient, and you're able now to apply it on data. So I'll hand over to Benjamin, I guess. Yeah.
Yep, I'll share my screen. Yeah, thanks, Alan. Yeah, and I think that, did I share it? Yep. I'm not sure if that's correct. You can see my screen, right? Yes. Okay, cool. Yeah, so thanks, Alan and Helena. And I think that I just want to iterate that annotation process is really important. And I'm going to try to look at why, and also in relation to what Helena's saying, I'm also going to look at some of the pitfalls of why why a modeling process doesn't work. It might not just be that the model is trained on French and we're looking at a different language. There's all these different kind of things. So yeah, hopefully we'll get a sense of that. So the first thing is we need to assess how good the annotations are. And Alan talked about this disagreement metric and this disagreement, and we actually have metrics for producing that. And the reason why that's important is, if you remember these graphs of vectors of text space, if you imagine we've got this zone here in the middle, this is the disagreement zone, and we've got two numbers, the same numbers, but they've got different classes attached, labeled to them. And so the maths is not going to be as effective as if there's those are resolved. And so what we do there is, like we say, we come up with what's called interrelated reliability metrics, and that just tries to look at the level of disagreement across different kinds of text. And then, like they say, they do things to try to reduce the amount of disagreement. But you can, and so that improves then the model and its ability to find the pattern. And then another thing that can happen is, for instance, you can see this boundary zone, is that you might have a space where even though you've resolved the disagreement, you have like on one side you've got positives, and one side you've got negatives, you've got hate speech and not hate speech, and the model can't then again discern the pattern, and this is called like the signal versus noise problem, and signal is the idea that there is a pattern, and noise is the things, the random other information that's getting in the way of the pattern. And the noise brings ambiguity to the model and reduces its performance and its ability to make predictions. And so, like Alan's saying, an important annotation guidelines, annotation training, resolving disagreements, doing iterations, and then also there's other kinds of techniques that you can do. For instance, you can also, if there are disagreements, you can do majority voting. So you say, okay, we're going to take the label that has the most votes and like that kind of stuff. And these are all ways of trying to improve the level of signal. And so once we've got that, then we can start building our fine-tuned model. And just to remind you, we've got the annotations, the information, we get the embeddings, aka the text to vectors, then we fine-tune it, we compute the patterns, and then we get the recipe. Great, gold star, we did it. But what did we do? Yeah, like what does this say? How do we know how good our model is? Like, yeah, it's like knowing how good we are, knowing how good something is, how it performs is really really a hard thing to do. And like being able to say, like, with the examples that were developed, like how well is it going to perform to a new example? How well is it going to generalize to things that it hasn't seen? And on top of that, like if we try to change the model, say we added some new annotations, or we try to do some clever math stuff, like it like, is it improving or is it making worse? And this like this ability to say what's better and what's worse is really key to understanding the performance, and it's a very tricky problem. And on top of that, we've got another problem. We've got this problem, bias. Yeah, humans are good at finding patterns and believing and convincing ourselves in patterns that that are maybe just false and full of bias. And like at its worst, bias can can lead us to classify like a loving, friendly person that looks like this to being evil and doing terrible things to this. So it's actually a serious thing. And I think that at all points in our analysis process, we should be considering bias and its effect on us, and like its effect on the fine-tuned model, but also on the conclusions we make in general. So how do we stop bias, and how do we understand the performance of our model? So we measure the performance on data that it didn't get trained on. So like Alan said, we create that annotation set, and then we split it up into what we call a test set, training set, and we have lots of different sort of variations of this, of having a validation set and those kind of things that I won't get into detail about. And the important point is that it's random. So we use randomness to try to make it statistically correct. And yeah, let's have a look at like what the intuition of how this might look like and why it's important. So we'll go back to our funny model graph again. So say these are the annotations that we're going to chain the model on. And this is the model that we have. So we've got the blue ones, which are negative, and the aka they're not hate speech, and the red ones, which are positive. And you can see there's not a very big wide, they don't cover the space, these examples, they're just quite clustered. And the model, the maths, the ML has decided that the best line is the one you see here going across. So let's see if that's the best. We're going to try it on a test set. So here we have a test set, and you can see the position is the predictions. So you can see these two in the corner, it got correct. The test set, the annotators said this example on the far left is negative, and the model said that as well. But on the far right, the annotators said this example is positive, and the model said it's negative, so it's wrong. And we call that a false negative, aka the model, the prediction was false. It was incorrect. It was an error. And then we have some correct positives, true positives as they're called. And then we have at the top here, these blue ones that the annotators said they're false. I mean, they're negative, sorry. And but the model is predicting them as positive. So again, they're called false positives. That's another error. So these give us a sense of like, these things are incorrect. These are errors that the model has in its prediction. And then from that, we can like get some performance metrics. So for instance, we have something called precision and recall and F1 score. And these are like these are really hard to get your head around. So I'm not going to go into them in depth. I'll try not to. But the important intuition that I'm going to give you is that we can use these metrics to understand what direction we're going in. And like, for instance, you can optimize your model for different kinds of metrics, which hopefully gives you a sense of what they mean. So for instance, if you optimize precision, this is really useful, for instance, if you're trying to build a Face ID authentication classifier, because you don't want to make a mistake. You don't want to have a picture. You don't want to have my cat and it mistakenly gets like positively classified for my face. It needs to be very precise. It needs to not make mistakes. Recall, on the other hand, is more useful. Optimizing models for recall is more useful for medical diagnosis, where you really don't want to miss a positive example, right? You want to make sure, like having a mistake on a positive example, someone that, for instance, doesn't have an STI, but they've been positively predicted. That's not a big deal, They just go and whatever, they take the medicine or they don't. But missing people that do, that's a big deal. So optimizing for recall allows us to make sure that we're not missing any positive examples. So again,
Benjamin, can I give a peace building related version of the precision and recall examples? Because I think your medical ones are like super good because you can get your head around them so quickly, and I've heard those before from others at DVP, and it was really helpful. I think the way I translated it into kind of the work that we do is that if what you're trying to do is to very quickly take down the most heinous hate speech, then you want precision, because you don't want to be asking for takedown of things that are not actually positive, right? So that's what you want to go for. Versus if what you're looking at is you're trying to do narrative analysis, so you're trying to get us like you don't want to miss any of the positive examples of hate speech, like any of the actual hate speech, and you don't mind getting some stuff that isn't hate speech, because when you're doing your analysis you can discard it, then you want to go for recall. So you can then translate that into any other kind of version of that, but it's like, how important is it to like make sure that everything that you're getting does fit that category, versus making sure that you're not missing any of the things that are in that category, even if you're getting some junk, which you can then through other processes, figure out. So depending on what analysis you're doing, that's what you want to think of.
Great, exactly, great examples. And then the last one, the F1 scores, are kind of like a sense of, based on the precision and recall, how well is the model doing in general? And most of these are like fractions, so they're a number between 0 and 1, and 1 being better and 0 being less good. So what do these performance metrics say? We've talked about like what it means to optimize for one, but like good performance metrics means that like the classifier is generalizing to the test set or the validation set. So it's able to say for a data that's not seen, it's working well. AKA the lines that are being created seem to be predicting the same things as what the test or the validation set is. And there's a very like hard bit now. It's like this idea of bias and underfitting and variance and overfitting, and that's really tricky. And that's something that I think that you should watch the Google ML thing about if you want to get into that. Because to be honest, I think I'm probably the wrong person to talk about that further. But in any case, just to be aware of those things and to be aware to think like they're huge problems within modeling processes. And then the last thing I want to just mention is we have been working with models for a while, and the things we've started to notice is that like measuring prevalence, aka the percentage of something with a model, it can be problematic. And this is because if you have small amount of, like, for instance, hate speech or something like that, let's say 1% of your total discourse is hate speech, then it's very hard to say the model is doing well or not. So it's just a measure of saying be careful, and if you want to make sure that you're statistically working well, you should actually, I'd recommend using like annotating a random sample, because statistically that's easier to understand and easier to validate than building a model for prevalence. Yeah, so conclusions. Did we miss some conclusions here from you guys? Or
It looks like the slide didn't update. There's one more.
You need to refresh.
That's good.
okay, let's have a look. I'll refresh.
There we go.
There we go. Yeah. So yeah, the iterator reliability is important, and we're going to talk about that in depth in the next session. Like using performance of a randomly selected tester is about how you're trying to understand the bias and the variance of your model and how well it generalizes to new data. And then the other conclusion is from the other guys.
And I think the other conclusion is just to think about like what is the use case for your model, in relation to your peace building objectives. So that was a little bit what I was trying to say when I was talking about, do you care more about precision or recall, because it kind of depends on what you're doing with the model. But one other thing that I would say, which is related to this point about prevalence that Benjamin was saying, that Benjamin was talking about, is that in order for the model to be fine-tuned well, you need to have a high percentage of positives in your data set and the data set that you're using to train. And so you're kind of in this situation where, like, if you take a random sample of social media posts, you're likely to have a very low prevalence or a lower prevalence of positives of whatever it is you're looking for than if you go looking for them. But then if you go looking for them, you're automatically using a sample that is somewhat biased by the search terms that you've used to look for it. So there's kind of a bit of a tangle here. And so you have to think about, like, why is it we're building this model? What are we trying to do here? Why is it important to be able to reclassify and systematically find this particular thing? And kind of what's the objective down the line? So if the objective down the line is to be able to say X% of content on this platform contains hate speech terms, then just be careful, because that's quite a hard claim to make, actually, when you sort of get into the detail of it. And hopefully we've shown you a bit of that. But if the objective is to say, we're going to try to find lots of the hate speech narratives because then we want to do something about it as peace builders, then that might be actually a slightly easier thing to do.
Exactly. Unless Alan wanted to do any concluding points, because I forgot him.
Yeah, I just wanted to basically say, you know, if you're thinking about applying you know, a classification on Phoenix and you have a Phoenix account, as an example, all you need to do is, you know, log into the platform. There's this section that is called classify. So you'll see on your dashboard, there's this section that is called classify. And if you click create, you'll see the options that we've discussed today. So how do you build a keyword text classifier? How do you apply Perspective API that is already here? And all you need to do is just, you know, turn on the flags that you need to test your data on. And if you're thinking about an open source classifier that is on Hugging Face or something that you built yourself, you can just use this final option where you kind of just click start applying and you use that. So this is available within Phoenix, and this is where you find it in case you have an account. Thank you. Yeah.
And instructions on how you might upload a classifier to Hugging Face, which is how they get onto that open source classifiers bucket that Alan just showed, and how you can request access to Phoenix is in the chat.
Okay, thank you all. It has been a constant mission of Build Up and also Data Value people to de-hype, demystify, debunk, pull behind the curtain, show how it's made so that people can use it for their own purposes. So we now have time for questions. If you know, that was presented really simply and clearly in that same sense, but also if you're hearing these things for the first time, precision, recall, false positives, you know, you're allowed to have questions, and there's no question that's too basic. So we have one to start with from Lisa, who says, are there criteria being used to identify hate speech instances, or this just the intuitive sense of the human you mentioned doing the labeling? Yeah, so like, how do annotators and criteria and annotator training work?
You want to go first, Helen?
Yeah, sure. So I think it's basically, for us, it's usually like what do people in a specific context agree on? Because essentially what I've seen in the past is that especially when you're focusing on hate speech, what you would need to do is actually to develop like a lexicon and then workshop that across a number of people so that you also don't have that disagreement, because hate speech is quite, you know, specific in some contexts. And sometimes hate speech is not just content that is one word. It could be a phrase, it could be something like that. So even when you're building an annotation set or like a training set, it's a matter of like agreeing together between people from diverse contexts so that you're not even biased in your labeling or annotation in the end. So that is a really, really important part, especially when you're dealing with hate speech compared to other types of classifications. Yeah.
And maybe the one addition from that is that like our human understanding of patterns is not fixed, right? So like we all have this, maybe you could say intersubjective reality of understanding this pattern of hate speech, but it's not fixed, and also over time, and it's not fixed like in regions. So it's very hard to come up with like a general objective idea of hate speech. And I think Alan's idea of saying making it context specific, not trying to say we are the bosses of hate speech, but we're looking at this specific context and we're coming up with very specific ideas of what is affecting social media or the conflict in this way. That's the way to I think to call it.
I wonder if one of you would share maybe a more ambiguous concept than hate speech too, because this is like, how do you operationalize a concept that's not so clear as hate speech?
Yeah, so maybe can I talk about the polarization one a little bit, Alan, and you can like jump in as well. So one of the classifiers that we've been working on is a classifier of what we're calling attitude polarization, which is a subset of affective polarization. And I've now used two terms that probably mean very different things to everybody on this call. So let me try. So we had to go through a whole process of basically agreeing internally what that means. So like affective polarization is not a strong disagreement about ideas, but essentially where you disagree primarily based on who is saying what. So it's a disagreement between people. It's a sort of a sentiment towards another group, an other group. And attitude polarization within that is essentially the component of affective polarization that has to do with your sense of the other group and of the other group being different and separate from you. So it's everything from things that could be termed as hate speech, so dehumanization, vilification, de-individuation, but it's also stereotyping and generalizations. So things like, people from that group always do X or always say Y. And that kind of thing that creates essentially distance from the other group and then allows for affective polarization. And I think, so Julie's just posted some links and we've written loads about like what we mean by that. But that's great. We'd written all this stuff. And then like we started to define what we meant by that. And we wrote, maybe a page document of what we meant by that. And then Alan and Caleb, who are like really close to this work, they've been part of writing these archetypes, they've been around Build Up for a long time. They go out and they try and find examples, and they come back and they've disagreed on, it was like 10%? Like they disagreed on like
lot, yeah.
1 out of 10 they weren't agreeing on. We were like, oh dear. And so then we had to have a discussion about what were the specific elements of this definition that actually, when you operationalize it, get really sticky. And this is I mentioned it briefly before, but it was this point about rudeness. If I say, F your brother, is that polarization? Is that attitude polarization? If I say, F your brother because he's like all these other people, is that affective polarization? If I say everybody from that group can't dance, is that affective polarization? If I say everybody from that group, is stupid, is that affective polarization? And we had to go through all of these different kind of scenarios and decide where these sat within the definition. And I think that so it's a very kind of contextual, complex issue. And then it got more complicated when we brought annotators in. And I'm sure you'll hear some of those stories in the annotation webinar as well.
Okay, we have a couple of questions about open source. So we've said open source, like I think we're taking for granted open source. So maybe like what do we mean by open source? Where can folks find things? Where could they upload things if they wanted to do that? Like, can you talk more about that open source ecosystem?
Benjamin, I was wondering whether you have handy the Hugging Face. So the first point was about the Hugging Face classifiers. Do you have our profile on Hugging Face or your profile on Hugging Face handy so we can post it here? So essentially we post the classifiers that we work on Hugging Face once we are satisfied with them. So for example, the Kenya one we haven't posted yet because we're not done. And hopefully Benjamin's about to post the link and then you can just find them there. Abdulrahman, I think your question was about Phoenix. And if I'm right about that, then the answer is that Phoenix is already open source. The code is linked on the Build Up website, but we can also just directly post the link to it here. And maybe, Benjamin, are you about to do that or shall I grab it?
for Phoenix, I can do that as well. Yeah.
You can do that as well. Okay, so the link to the code for Phoenix is on there. So I think maybe what we should say, which we didn't say, is that when we say you can apply for an account, we host a version of Phoenix, and access to that is free for anyone who is a peace builder or a mediator or does adjacent work to either of those fields. So you fill out the application and then we give you an account. And also, if you are somebody who can deploy your own code, then knock yourself out. There's the code, and you can use it. So yeah, I think maybe that explains the difference.
Okay, any last questions before we wrap up? If not, okay, reminder, this recording will be posted to our webinar Build Up YouTube channel, and I will send an email after it is. In the chat, you've just received a bunch of links. I can also share those after. And we've talked a bit about annotators and sort of how do annotators fit in this process. But this is part 1 of this particular series. In part 2, we're going to be talking with annotators, just with annotators, to see like to dive more deeply into some of those sticky areas that we covered at the end in the questions about operationalizing concepts. And so on November 7th, at the same time as this webinar, we'll have another one with annotation experiences to cover all of that in more depth. And I will send an email to everyone who's registered with this one for the next one. So you should get that in your email. And yes, let us know if you have any questions in the meantime. Thank you all for joining. Thanks, Benjamin and Alan and Elena.
Thank you.
Thank
Bye.
you, everyone. Have a good one. Bye.
Bye. Thanks very much.